Hi everyone. In today's video, I'm going to show you how to find the course and distance made good without actually doing anything on a chart. So you don't need to use chart work, but basically the principles of the nautical mathematics to find out the course and distance made good. So the only drawing we'll be doing is today drawing on this particular screen. Now we'll not be using any kind of paper charts or electronic charts. All right, so the question is that there is a vessel that is steering 072 degrees true at 10 nautical miles per hour. Remember that, that's very important. There is a current that is setting at 100 degrees true at 5 nautical miles. Again, this is per hour, which is very important. You have to find your course made good to the nearest degree, of course. That means that keep it to a whole number, not in a decimals, because we don't steer courses in decimals, isn't it? And then the distance covered as well. So the distance made good if the vessel sails for 3.5 hours. So remember, this is very important here to understand that the speed of the vessel and the current's rate is given at per hour, but you have to find the course made good and the distance covered if the vessel sails for 3.5 hours. All right, so let's start firstly by drawing a diagram. So we don't use a chart, of course, but we'll draw a diagram, and this is the most critical part of you understanding this question and then being able to solve it. All right, so here is a vessel. So draw big diagrams on your paper so that you can understand what's happening here. So this is a vessel that is sailing 072 degrees. So say this is the north, this is the south, this is the west and east. If you are sailing 072 degrees, something like this, let's say, all right, 072 degrees, that means that angle of 072 degrees, I will use a different color pen, is measured from here to here is 072 degrees. It's measured clockwise from the north pole or the north direction. All right, that is 072 degrees. So that is your vessel's course that it is steering, and we will draw the diagram for 1 hour only. The triangle that we will draw will be for 1 hour, and the values that we can find will then be multiplied by 3.5 hours. So the triangle that we will draw is for 1 hour. Remember that. Now the course made good, doesn't matter if you draw the triangle for 1 hour or 3.5 hours, it remains the same. You don't have to multiply it by 3.5 hours. But the distance that you will find out in this case will be for 1 hour, because we are drawing a 1 hour triangle, and you will multiply it by 3.5 hours to find the distance covered in 3.5 hours. Let's see how. So I am going to draw a 1 hour triangle because the information given to us is 1 hour. This is what we also do in chart work. All right, so if we are drawing a 1 hour triangle, that means the vessel is drawing a course of 072 degrees as measured clockwise from the north pole, and you are doing or not you, but your vessel basically is doing 10 knots an hour, 10 knots per hour. That is the speed of the vessel. Now let's say this is the line that I have drawn, and is 10 knots. If we were drawing it to scale, it would be, and it was 1 centimeter equals 1 nautical mile, it would be 10 centimeters, but we don't worry about that because we are going to use maths. We are not using drawing. So this line that I have drawn denotes the 10 nautical miles that the vessel has steamed in the last 1 hour. Then again you can draw here like a plus sign, because I'm going to apply the current now. So the current that I will apply, and I will just use different colored pens so that you understand what's going on here. So remember, the current is setting at 100 degrees true. So if it's setting at 100 degrees true, so currents normally come from and winds go to. So current is coming from 100 degrees true, something here like this. All right, this is 100 degrees true. Now why is this 100 degrees true? Because again, if I call this north, I measure out this angle here, this angle is 100 degrees true. So this is 100 degrees true. 90 degrees is from north to east, and then further from east going towards south we have another 10 degrees. So total is 100 degrees, and current is setting, denoted by triple arrows, is setting from 100 degrees true, and the hourly rate is 5 knots. Remember that we are only drawing for 1 hour of a triangle. So when we are drawing for 1 hour of a triangle, so this blue line denotes the 5 knots, the black line denotes 10 knots, and then what I will do is I will join this point to this point here, and this double arrows will be denoting the course made good, the course made good, because the current is acting on the current course. This distance that we find, this distance is of course distance made good. We can call it DMG, distance made good, but this is for 1 hour only. All right, the course made good that you will find will be for 3.5 hours. Although we are using the 1 hour triangle, the course made good you don't have to multiply by 3.5 hours. Only the distance that you find from this triangle is applicable for 1 hour. So this distance made good will be multiplied by 3.5 hours to find the distance covered in 3.5 hours, because that's what they are asking you to find. All right, but before we do that, let's understand this triangle here. So this triangle, I have explained how the 72 degrees is measured and how 100 degrees is measured, and the black line denotes 10 knots, the black line with the single arrow denotes 10 knots, and the blue line with triple arrows denotes 5 knots. All right, so now let's see what else we can find out. Now, because this angle here is 72 degrees that you can see, this angle here and this angle here, this angle here are called complementary angles. So because it is like it's like a parallelogram if you think about it. So if I kind of, if I had drawn it like this here, if I draw it like a parallelogram, these red dotted lines, it becomes like a parallelogram, right? It's like a rectangle and parallelogram. So in this case here, and if you don't understand this concept, don't worry about it, just take my word for it, that in this case here, this becomes like a, what we call, the word is complementary angles. That means that angle and this angle here is the same. So if these two angles are the same, then we number this 72 degrees as well. All right, this is 72 degrees. Now this angle here from E going to south, denoted by blue, is 10 degrees. Why? Because north to east is 90 degrees, from east to south is 10 degrees, together it's 100 degrees. That's why the 100 degrees was the current that was setting, right? But this part here is 10 degrees only, right? If this part is here is 10 degrees and from east to south total is 90 degrees, that means this angle here, that I should probably draw with a different color pen, this angle here, the black part will be 90 minus 10, which is 80 degrees. All right, so if I can explain this, so again, so 72 degrees is forming a complementary angle here, so this becomes 72 degrees. Now look at the angle between east to south. Now the 10 degrees of that is already been used for the current, so the remaining 80 degrees between east to south is then forming this angle here, right? So we've got 72 degrees and 80 degrees. That means the total angle that I have measured here, the total angle is 80 plus 72, which is 152 degrees. All right, so if I have to zoom in and I have to show you what I mean, this is what I mean. So this north to east is 90 degrees. There was another 10 degrees that you took up because you were trying to measure out a total of 100 degrees of current being set, right? So the remaining angle here from east to south, the remaining angle is of course 80 degrees, 90 minus 80. All right, and then the other angle that you measured was 72. So the total angle will be 72 plus 80, which is 152 degrees. So we consider this to be a triangle about which we know only a few things and we have to find out the rest. So if I really zoom into this triangle, or if I have to highlight what this triangle is all about, this is a triangle like this. All right, this is a triangle like this. This is the triangle we are trying to solve. So do you have found out this angle here as 152 degrees, which is 72 plus 80. This is 10. This is 5. And that's all you know. You don't know anything else. So if I call this A, B, and C, this is all you know. We don't know anything else. So the sides can be called, so the side opposite B, I can call it small b. The side opposite C, I can call it small c, and just denote it with a line through it, just to differentiate between the angle C and the side C. And the side A will be opposite to angle A, and I denote it with a small letter a so that I can distinguish between the angle and the side. All right. So now we will use the principle of SAS triangle. What is SAS? SAS stands for side angle side. Side angle side. Alright, how does this work? For this to work, if we know the included angle and the sides next to it, we can find out the rest of the parts. So that means I know the angle B and I know the sides next to angle B, which is side C and side A, so I can work out the rest of it. So how will I work out the rest of it? Well, the formula goes like this. So let's say you have cos B here that you know, which will be equal to A square, side A square, plus side C square, minus B square. Alright, divided by 2AC. That's the formula we will be using as per the side angle side principle. So in this case, you know cos B. Cos B is cos of 152 degrees. You know A square is 5 square plus C square is 10 square. You don't know B square, so I have to find out B square. That's the unknown. And then you have 2 times 5 times 10. Alright, now we have to solve this. So let's find out what is cos 152. So cos of 152 degrees is equal to, if I take up to 3 or 4 or 5 decimal places, it's negative 0.88294. Alright, 5 square is 25 plus 10 square is 100 minus B square. I'm doing it in steps so that you understand it. And then 2 times 5 times 10 is 100. Now I take this to the other side. This is transposition. So when I take this to the other side, I multiply it. So negative 0.88294 multiplied by 100. And this 25 plus 100 is 125 minus B square. Alright, so this multiplied by 100 gives me a negative of 88.294, which is equal to 125 minus B square. Now what I will do, I will try to make the unknown positive. So I will bring it on this side here. And I will take this number here and take it to the other side. So I will take my knowns to one side, all the numbers that I know, and the unknowns on the left hand side. So unknown comes on the left hand side, becomes a positive number, B square, and this becomes 125 plus 88.294. So now it becomes a positive number. It's no longer a negative 88.294. So that means B square equals 213.294, or B equals square root of 213.294. Square root, we call it underscore. Sorry, underscore. I can't remember. I've forgotten. So it's called square and square root. Yes, I think it's called square root. Correct. I'm just confusing myself. So in your calculators, just press the button of square root, put the number 213.294, and you will get the answer as B equals 14.6. Alright, so B equals 14.6. Now in this case, we will call this side B 14.6. Now remember, this 14.6 is the distance made good in 1 hour. In 1 hour. But you have, because this was a 1 hour triangle. Now if you want to find the distance made good in 3.5 hours, which is the question here, all you have to do is basically distance made good in 3.5 hours. You just take this number 14.6 and multiply it by 3.5, and the answer you will get is 51.1 nautical miles. So you have traveled 51.1 nautical miles is the distance made good in 3.5 hours. So one part of the question is done. Now I have found out B. Now the one that I have found out is course made good. Now to find course made good, basically remember, to find course made good, you have to find this angle here going up to north, this angle, the big angle here. This is the course made good, measured clockwise from the north pole or the northern hemisphere or the north direction. You have to measure it clockwise. So that blue angle here, now you already know 72 degrees. So if you just find out this angle here, you can just add to 72 degrees and it will give you the course made good. Right, so this angle is course made good, course made good, CMG, course made good. You already know 72 degrees, and then if you just find out the portion in the triangle, if you just find out the small portion in the triangle, that is angle A. If you find out angle A in this triangle, you can just add to 72 degrees and find the answer. So how do I find out angle A? Again, use the side angle side principle. Now you know side C as well as side B and side A. So if you know three sides as well, you can find out the rest of the part. So this will be cos of A. So let's put it in the formula here. Cos of A is the angle, and then the sides which are next to A, which will be B square plus C square minus the side opposite to A, square of the side opposite to A square, divided by 2BC. Alright, divided by 2BC. Divided by 2BC. That's right, divided by 2BC. So because correct. Alright, so that means that we don't know cos A, so we have to find out cos A. So B square is 14.6 square, very good, plus C square is 10 square, A square is 5 square, divided by 2 times 14.6 times 10. Right? So the answer you will get is, of course, 14.6 square. If you do that, you get 213.16 plus 100 minus 25 divided by, this is equal to 20 times 14.6. So I'm just doing the question as with you, 292. So this is, remember, this is cos A. You have not yet found A here. So cos A equals, if I add the two, 213.16 plus 100 minus 25, I get 288.16 divided by 292 is equal to 0.98684. So A will be equal to cos inverse of 0.98684. So shift cos inverse, you will get the answer A equals 9.3 degrees. Now A is degrees, not nautical miles, it's an angle. So this is 9.3 degrees. Now if this is 9.3 degrees and I know that for this part here is 72 degrees, right, this is 72 degrees, then course made good will be 72. Course made good as per this diagram here would be 72 plus 9.3 degrees, which is equal to 81.3 degrees. Now because we don't steer courses like in decimals, so here the answer will be 81 degrees. 081 degrees true as measured clockwise from the north hemisphere is the course made good. Alright, so watch this video carefully, label the triangle carefully. Only the first part is a bit tricky, where you're trying to find the complementary angle and the other part of the angle, and then you're trying to add them. Finding this part is the trickiest part, but just watch this carefully and hopefully you will get it. I will try to put up more examples if I can, but watch this part and let me know if there are any questions. Put it in the comment section and I will try my best to answer them as I can. Thank you very much for watching this video, and bye for now.